Hello, everyone. This is a last-minute Unit 4 test review that I urge you to follow, to pay close attention to, and make sure that you understand because it will be similar to your upcoming Unit 4 test. With this being said, let's get started. So for number 1, the question asks, it says you're thinking of joining a Taekwondo club and have two to choose from. So 2 clubs to choose from. The first club charges $30 to join and $40 each month for 1 year. This cost can be expressed as f of x equals 40x plus 30. The second club charges a fee of $70 to join and $30 each month for 1 year. This cost can be expressed as g of x equals 30x plus 70. Now, the first part says, the part A, graph each equation and identify the appropriate line with f of x and g of x, label the axes. So basically, you're being asked, so make sure that you see or you highlight the action verbs. You want to graph each one of them, each equation, identify the lines, and then label the axes. So you have 3 things to do. First of all, let's label maybe the axes. So the x value here, what does the x value represent? Remember, the fees are $30 for the first club and $70 for the second. But then the monthly charges are $40 for the first club and $30 for the second. So this x here, since you have the monthly charge attached to them, the x represents the number of month. So on the x-axis, you're going to say number of month. So this is month 1, 2, 3, 4, etc. Okay. On the y-axis, you have the f of x, the function or the fee. So here's basically the charge or the cost. You may want to call it charge / cost, and the unit for that is dollars. Okay. So this is how you label the axes. This covers label the axes. Then the second part is graph. So how do we graph this? So let me color code them here. So let me maybe put this one in blue and maybe one in green, right? So this is going to be in green, and or maybe something like this versus something like this. Okay, so I will graph f of x starting at 30, which is the y-intercept. And then my slope is 40. So I'm going to go 40 is 40 over 1, if you remember. So I'm going to go 40 up. From 30, 40 up is going to be 70. So I go 70 and 1 to the right. I'm here. And I can do that repeatedly. Or if this is sufficient, I can graph. Remember, when you're graphing, you're using a ruler. And you're graphing a line that passes through both points. Make sure your graph is accurate. Okay, and once you graph, you're done graphing, you label this f of x. So again, you're using a ruler to graph with the arrows on each end, and then label f of x. For g of x, we're doing the same. However, we're starting at 70. So we're going to be starting at 70 because that's the y-intercept. And from there, we're going 30, which is 30 over 1. So 30 up. From 70, 30 up is 100 and 1 to the right. You can go 30 more up and 1 to the right again if you want to do that. And so on. You can keep repeating that, right? If you have room, you can keep doing that. Okay. Now, once you graph this line, it's going to look, I'll fix it. It's going to look something like this. Okay. And you will probably be able to see where these 2 lines are going to meet. All right. So now the question says, so I graphed check mark. I identified the appropriate lines. I did that with f of x and g of x. I labeled them. Well, actually, I need to label g of x still. So g of x is this line, the line in green. Or you can label it on this end if it feels too crowded up there. If you have a pencil and a colored pencil, maybe that's a good idea. Graph one line with a pencil and the other with a colored pencil. Now, that's the first part, so we're done for that. For part B, it says use the graph to determine at what month f of x is equal to g of x. No, look at the graph. By looking at the graph, you can see that both of these lines meet at this point. Okay, and you're interested in determining the f of x, the x value for which these two lines meet. So it looks like they both meet for x equal to 4. Remember that says the question says use the graph to determine at what month. So they're looking for the x value. So f of x equals to g of x. You can say for x equals to 4, or at the 4th month, or month number 4. Okay, or for the 4th month. So now let's go on to part C, which is show algebraically when f of x equals to g of x. And when they say show algebraically, you're going to set these equations equal, and your answer should be this exact answer. If it's not, something is wrong. So we're going to set f of x, which is 40x plus 30, to be equal to 30x plus 70 and solve. So first things first, we're going to subtract 30x from both sides. Again, I prefer to have the positive amount of x's on the left. So here I subtract 30x, and this will give me 10x plus 30 equals to 70, because the 30x is gone from here. And then the second step is to subtract 30 from both sides. And this will cancel the 30 from this side and will give us 10x equals to 40. And then the last step is when we divide both sides by 10, we get x equal to 4, which confirms the result from this part graphically. Okay, so this is algebraically what we just did, and it confirms the graphical solution. Okay, that's number one. Number two is to solve the equations for x, show all work. So make sure you understand this part number one, go back, pause if you need to, etc. For question number two, we have 3 parts here, A, B, and C. So for part A, the question is asking us to basically solve for x, and same thing for B and C. So let's start with part A. So first things first, when you look at this equation, you see like terms here, 7x and 4x, so minus 4x. So you subtract 7x minus 4x, that's 3x plus 2. Anytime you see like terms, automatically combine them, okay? And on the right-hand side, you can either rewrite it as is, or if you want, and if you're comfortable, you can automatically distribute the 2 in, and this will give us 6x plus 4. Okay, there's nothing wrong with that. So again, you can combine the like terms, 7x minus 4x, and that'll give you 3x. And simultaneously, on the right-hand side, you can multiply the 2 in to get 6x plus 4. Then you subtract, let's say, 6x from each side. I just moved all the x's to the left, and this will give me negative 3x, because 3x minus 6x is negative 3x plus 2 is equal to 4, because the 6x's are gone here. Then subtract 2, you get negative 3x is equal to 2, and therefore x is equal to negative 2/3, because you're dividing by negative 3, both sides. Okay, so again, you combine the like terms, get 3x plus 2 equals to 6x plus 4, and then you subtract 6x, you get negative 3x plus 2 equals 4, subtract 2, and then divide. Okay, so make sure you remember these steps. Part B, same idea. You start with negative 3x plus 2 equals, there's not much going on the left-hand side. On the right-hand side, you're going to multiply the negative 2 in, and this will give us negative 8. Negative 2 times 4 is 8. Negative 2 times positive x is negative 2x. Okay, and then you're going to move all the numbers to one side and all the variables, or the one variable, to the other side. So if we add 2x to each side, this will give us negative x plus 2 equals negative 8. And then subtract 2. And again, if you add the x's to the left, you want the x's on the left, that means the values or the constants, the numbers are going to be on the right-hand side. Subtract 2, you get negative x equals to negative 10. And therefore, either by multiplying or dividing by a negative, you get x equals to positive 10. Or you technically switch the sign of both of these sides. Now, you want to double check, you can plug the 10 back in here, right? You can check, you can say negative 3 times 10 plus 2, and you want to see if that's equal to negative 2 times 4 plus 10. And you can check negative 3 times 10 is negative 30, plus 2, you know that's negative 28. On the right-hand side, 10 plus 4 is 14 times negative 2 is also negative 28, they check, okay? So this is one way of checking the work, and you can have done that with the negative 2/3. Maybe a little bit more tricky, but it's possible to go back and plug it in, it's not too bad. For part C, you have a fraction on the left-hand side, 3x minus 7 over 3 equals x plus 5. Now, first things first, what I would do, because I can see a fraction divided by 3, so I would like to multiply both sides by 3. And careful, when you multiply both sides by 3, you're multiplying everything on one side and everything on the other side. So when you multiply the left-hand side by 3, this 3 will cancel with that 3. That's the purpose for you to multiply by 3. That's the reason why you're multiplying by 3. And this leaves us with 3x minus 7 equals. The right-hand side, x plus 5 times 3, you're technically distributing the 3 in. So this becomes 3x plus 15. Okay. Now, when you see this, this is a red flag. You can see you're saying 3 times the number minus 7 is equal to 3 times the number plus 15. And you automatically see that something is wrong with that. And if you don't, that's fine. What you could do, you can maybe subtract 3x from both sides, and you'll get negative 7, so the 3x's are gone, equal to 15. And you know negative 7 is not equal to 15. So the answer to this is what? No solution. Again, the reason is because you got something that is incorrect, that is false. Negative 7 is not equal. It's not a, this is not a true statement. So therefore, there's no solution. This is number 2, parts A, B, and C. Moving on. Number 3, solve the equation for the indicated variable. So this is lesson basically 4.4. This is part of literal equations, solving for one variable. So we're solving for A. We want to isolate A. We want to get A by itself. So again, you work from far to near. You start by subtracting K from both sides. You get 40 minus K is equal to AB. And then you clean what's right next to A, which is B. So AB is A times B. You want A by itself, so you're going to divide this side by B. But again, you're going to divide the entire left-hand side by B. Careful. You're not just dividing the 40. You're not just dividing the negative K. You're dividing the whole side by B, just like you did on the right-hand side. And by doing so, these B's are going to cancel. You get 40 minus K all over B equals to A. Or you can switch the items. You can write A on the left, 40 minus K all over B. That's the same thing, okay? It's kind of like saying if x equal to 2, or if 2 equals to x, that means x is equal to 2, right? By the commutative property of equality. Now, this is not the case for inequalities. With inequalities, you cannot just swap. If you swap, you have to switch the inequality sign. But for equations, you swap and you should be fine. Part B, you're solving for y. You want to isolate y. So here's y. You want to get that by itself. You start by adding 3x to each side. You get 5y, because by adding 3x, this is gone. 5y equals 4 plus 3x, or 3x plus 4. And then divide both sides by 5. This divides by 5. This whole side divided by 5. The 5 here is gone. You get y equals 4 plus 3x equal to 5. Now, if you ended up writing this as 3x plus 4 all over 5, that's the same thing, okay? Again, because 4 plus 3x and 3x plus 4 are the same thing. So either or, you should be fine, okay? You write just one answer. I just gave you 2 possible answers, but you only box one answer out at the end. So this is number 3, parts A and B. Moving on, feel free to pause, go back and double check. Number 4, the question says solve and graph. So here you're solving and graphing. Not only you're solving, and they're inequalities, right? Look at them. They're not equations anymore. They're inequalities. So solve and graph. Starting with the first one, step 1 will be to distribute the 4. You can distribute the 4, or if you don't want to distribute the 4, you can see if you can divide both sides by 4. Because if you can divide both sides by 4, then the 4 is gone and you're left with x plus 8, right? So does 4 go into 56? And the answer to that is, yes, it does. It goes into 56 14 times. So you get x plus 8, because you divided here by 4 by 4. You get x plus 8 is less than or equal to 14. Now remember, because I divided by 4 and 4 is a positive number, I don't flip the sign, right? You only flip the sign when dividing or multiplying by a negative. So then you get here x plus 8 equals or less than or equal to 14, subtract 8, you get x is less than or equal to positive 6, and you're done. Now, let's say you didn't see that. This is method 1, right? This is method 1. Let's say you didn't see that. I'm going to do method 2. Method 2, let's say you didn't see that, and you ended up multiplying the 4 in. So you end up writing 4x plus 32 is less than or equal to 56. Is this okay? Yes, of course it is. You could have distributed the 4 in, and this is what you would have gotten. 4x plus 32 equals or less than or equal to 56. Subtract 32, you get 4x is less than or equal to 24, and then divide both sides by 4, you get x is less than or equal to 6. So either way, you should get the same answer. Your methods may be different, right? But at the end, the answer is the same. How do you represent? Remember, this part was solved. Now we need to graph. We have 2 action verbs, solve and graph. So the solving part, we got this done. The graphing part, not just yet. X is less than or equal to 6. Remember, when you have less than or equal, you're going close circle and to the left. Greater or equal, close circle to the right. Less than, open and to the left. Greater than, open and to the right. So the open circles is when you do not have an equal sign, right? And the close circle is when you do have equal signs. And greater is to the right, less than to the left. So we want less than or equal to 6. You start at 6, so you put a close circle at 6 because it's less than or equal to. And you want to go less than or equal to, that means you're going to the left. So make sure your line is clean. This is less than or equal. You don't have to extend it that far, but just make sure you extend it enough for me to know it's less than or equal to. This is nothing, okay? This is just was a separator between the 2 methods. Now, part B, and I'm going to separate again. Part B, again, you have an inequality. So you're going to distribute the negative 3 in, and you're going to distribute the negative 2 in. This will give us negative 12 minus 6x, careful with distributing negative, is less than negative 10 minus 6x. Okay. So then by you can add a 12 or you can add 6x, for example, to both sides. And if you add 6x to both sides, the x's are going to cancel, leaving us with negative 12 is less than negative 10. Now, here's the thing. When you get something that is always true, like negative 12, if you think about it, negative 12, right? Is negative 12 less than negative 10? Is this a true statement? Negative 12 actually is farther to the left from negative 10, so it is less than 10. Because this is correct, you would say what? Infinitely many solutions, right? Because it's always true. Which means no matter what you have plugged in the original inequality, it would have worked. Now, how do you represent that? Saying infinitely many solutions, because this is a true statement, is not enough. You would, on top of that, draw a number line right on top. Or if you want to make it like on top of it here, show it, that's fine. But this is more evident, right? The number line. This is to show when you draw a number line here on top of that, that's saying on top of the original line, that's to say that you understand that this is infinitely many solutions. Now, what if side here on the side, what if your final answer was something incorrect, like 5 is greater than 3, and you know 5 is not greater than 3, so you know this is incorrect? Then the answer to this would be what? No solution. And how do you graph no solution? No graph. You don't say no graph. You don't graph anything, right? You just leave whatever graph you have a blank, okay? So no solution. Again, infinitely many solutions, you graph a number line on top of the original number, on top of the existing given number line. No solution, something that is not true, no solution, you don't graph anything. You just leave it blank, okay? This is on the side here, okay? Now, part C, we're solving for 10 is less than negative 2x minus 9x plus 32. First thing I see like terms, negative 2x minus 9x. and this is going to become 10 is less than negative 11x. Just be careful, they're both negative. They become more negative when you add them. So 10 is less than negative 11x plus 32, subtract 32, subtract 32. 10 minus 32 is negative 22, is less than negative 11x. Now here's the deal. You have to be careful here. We have negative, we have x on the right-hand side. So how do we do this, right? If we divide, which we should, by negative 11 to get x by itself, two things happen. One, the inequality sign flips. And the second thing, negative 22 over negative 11 is positive 2. So you get 2 is greater than x, because this is gone. But then we're not done, because we don't solve for 2. We don't want 2 on the left-hand side. We want x on the left-hand side. If you get 2 is greater than x, that is incorrect. You don't want to, this is not your final answer. It's incomplete. So what you need to do is you want x on the left, 2 on the right. So technically you want to switch the 2 and the x, right? And because you did that, the inequality sign flips and you get x is less than 2. So 2 being greater than x is the same as saying what? X is less than 2. The only thing is that I want to start with x, because the x is being less than or equal to, the x is the one that we're graphing. This cannot be graphed. We don't know how to graph this. I mean, we can, but normally we graph x is less than 2, right? So again, the final answer must be x on the left-hand side. So it's x is less than 2, not 2 is greater than x. How do I graph x is less than 2? Open circle at 2, and of course, a line, basically a ray, right? That goes to the left. And this is basically how that goes. This is x is less than 2. Okay, so this is number 4, parts A, B, and C. Please make sure you understand them well. Moving on, maybe we'll do a couple more questions. Number 5, The Rock and Kevin Hart start mowing lawns to save money. The Rock already has $35 saved, and he charges $5 per lawn. Kevin Hart already has $47, and he charges $2 per lawn. Let x be the number of lawns. So how do we write a function? Let's write a function for the Rock. I'm going to use the letter R for Rock, so R of x. Make sure you always state in function notation, right? R of x. Even if the question doesn't say in function notation, try to write it as R of x for the Rock, for example. You can call it T for the Rock, right? But R of x, R for Rock. R of x is what? He saved 35 and is charging 5 per lawn. So 5 per lawn, that's your slope. That's your slope. And this 35 saved, that's your y-intercept. So this is going to be 5x plus 35. Similarly, for Kevin Hart, he has already saved 47 and then 2 per lawn. That's your slope for Kevin Hart, the 2 per lawn, and the 47 saved, that is the y-intercept. So I'm going to call it k for Kevin, k of x equals 2x plus 47. So these are the two equations that represent this situation. Now, part C, how many lawns will it take the Rock? How many lawns will it take the Rock to have what? More money. We want the Rock to have more money. So we want the equation that represents the Rock to have more money to be greater than the equation that represents Kevin Hart. And let's solve that. This is an inequality. So I'm going to set 5x plus 35, this is the equation that represents the Rock, to be greater than 2x plus 47. Okay. And let's solve that. So to solve this, we're going to subtract 2x from each side. And this will give us 3x plus 35 is greater than 47. Then let me just continue on the side. I'm going to subtract 35 from each side here. And this will give us 3x is greater than 8. So then I get to divide both sides by 3, and I get x is greater than 8/3. So one more time, 5x plus 35, that's the Rock, is greater than, you want the Rock to have more money than Kevin Hart, 2x plus 47. And then you subtract 2x from each side, you get 3x is greater than 47 minus, I'm sorry, 47, this is wrong, that's why. That's not an 8. That should be a 12. See, I made a mistake subtracting. So 47 minus 35 is 12. I'm thinking 37 minus 45, which is 1 negative 8. So 47 minus 35 is 12. So you get 3x is greater than 12. Divide by 3, you get x is greater than 4. So what are we saying here? We're saying for The Rock to be making more money than Kevin Hart, The Rock would have to mow more than 4 lawns, right? More than 4, not 4, more than 4. So to answer the question, how many lawns? To answer the question correctly, you can say, let's try to type it here. You can say The Rock will have to mow more than 4 lawns, or an acceptable answer would be The Rock will have to mow 5 lawns or more for him to make, or in order to make more money than Kevin Hart. Okay, so when you say greater than 4, that doesn't mean 4, right? It means more than 4. So you have to start at 5, especially if you're going with a discrete value, like it jumps by 1 unit. So it's 5 or more than 4. And that's number 5. Number 6, 3 parts, I think. Yeah, 4 parts. So number 6, solve each compound. Now we're doing compound inequalities. So how do you solve that? And you have an OR. So just be super careful with that, okay? Be super careful with the OR. So first things first, add 4 to both sides. You'd get 2x. The 4s are negative 4 cancel, less than or equal to negative 6. There's negative 10 plus 4 is negative 6. Divide by 2. You get x is less than or equal to negative 3. Or, you always copy the or down. On this one, you're adding 4. You get 3x is greater than 12. Then divide by 3, you get x is greater than 4. So this is your solution to this compound inequality. You want all the x's that are less than or equal to negative 3 or greater than 4. How do you represent them? Less than or equal to negative 3, solid circle at negative 3 and to the left. Greater than 4, open circle at 4 and to the right, and you're done. Part B, you have 3 is less than or equal to 1/3 quantity times quantity 2x minus 3, which is less than 4. So you're saying this is in between these two values, right? One way to solve this, one way to clean this up, especially the 1/3 here, right? And maybe let me use a different color. Let me see if I can move this up a little bit. Okay. So one way to address this is to maybe we want to get rid of the 1/3, right? And to get rid of the 1/3, it would be ideal to multiply all sides by 3. So you're going to multiply the middle side by 3, the middle item here by 3, this left-hand side by 3, and this side by 3. Okay? Just like you did with equations. You multiply both sides, but here we have like quote-unquote 3 sides. They're not really sides, but that's what they are, right? So that's what they look like. So if you multiply the middle part by 3, the 3 and the 1/3 are going to cancel each other because you're multiply 1/3 by 3, which is 3 over 1. So the reciprocals, right? They cancel out. This here, the left-hand side, 3 times 3, that becomes 9. And you copy everything else down. So 9 is less than or equal to, the 3 and the 1/3 canceled. You're left with 2x minus 3, and you don't even need the parenthesis, is less than 4 times 3, which is 12. Then you add 3 to all 3 sides. Again, whenever you add to one side, you add to all sides. And again, you don't add. I've seen students add twice to the same side. You cannot add to the same side twice. You only add 1 3 here, 1 3 on this side, 1 3 on this side. Now, 9 plus 3, this becomes 9 plus 3 is 12, which is less than or equal to 2x, which is less than 15. And then you divide everything by 2, divide by 2. You get 6 is less than or equal to x, which is less than 15 halves. So 15 halves, that's 7.5. So on one end, you always start with the lower end, which is 6. You have an equal sign here, so it's a solid dot. On the 15 halves, which is 7.5, you don't have an equal sign, so you know, again, 15 halves is 7.5, which is right here. This is 15 halves. You have an open circle. You want x to be literally between them. This is your solution, okay? Now, for part C, again, you have an OR. So you start by subtracting 6 from both sides. You get 12x is less than or equal to 24. 24. Divide by 12 on both sides. You get x is less than or equal to 2. And then remember, add 4 here. You get 2x is greater than 0. So don't cancel the right-hand side. There's 0 as a value, so just leave it there. And then, meaning 2x is positive. So divide by 2, divide by 2. That means x is greater than 0. So your answers are x is less than or equal to 2, or x is greater than 0. So how do we graph this? Less than or equal to 2 means close circle at 2 and to the left. That's less than or equal to 2. Greater than or equal to 0, or sorry, greater than 0 is open circle at 0 and to the right. So you want this or that. Now remember, we talked about this in class. We said, when you have an OR and the two lines that you end up drawing overlap, that means your final answer, which I'm going to graph in green, is really the entire line. You weld them together. So basically, you're saying you have all real numbers or infinitely many solutions. Think about it this way. Pick a number that is less than or equal to 2 or greater than 0. No matter which number you select, it's going to be one or the other. So we have infinitely many solutions. And again, the reason is not just because we have an OR, but we have an overlapping OR. Notice for part A, we had an OR. We had one going this way, one going the other way. They did not overlap, so we kept them, two parts, one to the left, one to the right. But now because they're overlapping, think about it as the OR when we had the rock picture, right? One had a goatee, one had a hair, or was combination, right? Combination here, because they overlap, combination would be the whole thing. You weld them together. Okay, so this is an example of an OR with infinitely many solutions. Part D, last part here, you subtract 7 from all three sides. Careful with the subtraction from all three sides. This 7 minus 7 is 0, which you write down. Copy the inequality sign. 3x less than 22 minus 7 is 15. Then you divide all three sides by 3. So keep the 0. 0 divided by 3, this becomes 0 divided by 3 is 0, less than, this is 1x or just x, which is less than 15 divided by 3 is 5. So you're saying x is literally between what? 0 and 5, open circle at 0, open circle at 5, and you want x to be just in between the two. Okay, and this is how this works. So please make sure you understand these differences well, okay? And this is pretty much our review for today. So please take maybe about half an hour to review this last minute. Make sure you understand it well. And best of luck to you tomorrow. Make sure you bring your packet. Your packet is complete. All the answers for classwork and homework are already on Canvas. So make sure you check those out, and your packet is complete and ready to be turned in tomorrow or Tuesday, depending on tomorrow is Monday, and November 21st is going to be odd, and Tuesday, November 22nd is even. So depending on which class period you have me, then basically that's when your test is, and that's when you are when the packet is due as well. Best of luck to you, and I'll see you tomorrow or Tuesday.